Formalizing functions and relations is where we take a lot of the smaller pieces of information about a function and we're formalizing. We're putting it all together. So we have a few things that we're doing today as far as our target. First, we're going to determine whether a relation is a function or not. We're going to identify the domain and the range, and then also learn how to use function notation. A relation. A relation is basically the pairing of two sets of numbers, the domain and the range. And you've seen relations, just not seen them called that. So you have relations, and that part of that is the domain. The other part of that is the range. And like I said, you already know these pieces. You just didn't know they were called that. The domain, that is the name for the group of all the x values, whereas the range is the name for all the group of the y values. So down here you see a relation. You see 4 coordinates there, -2 and 0.5, 0 and 2.5, 4 and 6.5, 5 and 2.5. And the dark red, that is the domain. So if I were to talk about the set of the domain, and we use these like brackets instead of parentheses so we don't think they are coordinates, let's get a different color. Let's go with black. The domain would be -2, 0, 4, and 5. And then the range is 0.5, 2.5, 6.5, and 2.5. That is the set of the range, which is all the y values. We use the domain and the range to decide if something is a function. I've got a couple of different ways for you to look at this. First is a mapping diagram, and that is one way to see if a relation, if a group of coordinates is a function. With a mapping diagram, you're looking to see if the x values are repeated, because in order for it to be a function, the x values cannot be repeated. So these coordinates, 2, 1, 3, 0, 4, 2, and 4, -1, if you put those into a mapping diagram, on the left you have all the x's. On the right you have all the y's. And I take those x's and I draw what they're connected to. Notice they're in order, 2, 3, 4, -2, 1, 0, 2. My first coordinate was 2, 1, so that 2 is matched with 1 as a y value. 3 is matched with 0 as a y value. 4 is matched with, actually down there, +2, and then 4 is also matched with -2. So you see how that x value is being repeated. So this is not a function because we have two y's, -2 and 2, for the same x value, 4. It isn't. So one way to remember this is to say it's not okay for a question to have two different answers. That we don't like. Something that somebody shared with me last year is that we get really mad if our x was 2 timing us. Or maybe you could say that's why they are our x now. So let's look at one that is a function. 1, -2, 2, 1, 3, 0, and 4, 1. 1 is paired with -2. 2 is paired with 1. 3 is paired with 0. 4 is paired with 1. We have two x's for the same y. So the number +1 is being repeated, but that is okay. It's when the x's are repeated is when it's not okay. So it is okay to have two questions with the same answer. So if you want to think about this mathematically, -2 plus 2 is always going to be 0, right? There's only one answer for that question. However, I could have two different questions that end up with 0. -3 plus 3 equals 0. And -1 plus 1 equals 0. That is okay. It's okay to have two different answers, two questions with the same answer. But it would not be okay if I said that something else was the same thing as -2 equals 2. There's nothing else that is going to have an answer of. That can only be 0. Another way to test if something is a function is using what's called the vertical line test. So these are the coordinates from our original problem that we wrote down before. I have already graphed those on you. There's negative 2.5, there is 0, 2.5, up here is 4, 6.5, and down here is 5, 2.5. I have me a vertical line right here, and you have a vertical line in your hand called your pencil. So you can always use your pencil, lay it down flat on a piece of paper. So if you when you go to draw this graph, don't worry about all these grids and everything, but draw your axes and put your dots kind of in the location where these are. Then you can take your pencil and you can drag it across there. So I'm touching that point right there, 1 point right there, 1 point right there, and 1 point right there. If the line touches more than 1 point at a time, it is not a function. So for instance, if I had added a coordinate right here, that coordinate is positive 5, 1, 2, 3, 4, 5. If I had added 5, 5 is a coordinate, notice that x value is being repeated. And when I do that and I pull my vertical line across there, I see that it's crossing 2 points at once, which is a no-no. That function then would not pass the vertical line test, and actually it wouldn't be a function. That relation wouldn't be a function. So here are some examples of functions. You can see right here, even though it has curves and bends, it's still a function, because if I were to drag that red line across there, it's only going to touch at 1 point. This is also a function because it's only going to touch at 1 point. Whereas this right here is not a function. You can see where that vertical line, that red vertical line, is through there, and it is touching right there, whoops, right there, and right there, which makes it not a function because it's touching the relation at more than one spot. Now let's talk about function notation. Y equals negative 4x plus 3. It can be written as f of x equals negative 4x plus 3. You see the difference is I replaced y for f parentheses x close parentheses. This is called function notation. F of x replaces the variable, and you read it f of x. F is the name of the function, not a variable, and it can have other names such as g or h, so it might say g of x or h of x. And it names the function because, as you see in our next slide, that could be significant of the real life situation it's representing. So for evaluating a function, let's take this one. W of x equals negative 250x. It represents the number of words, W of x, so you see why we use the letter W, you can read in x minutes. So what this is saying is for every minute I can read 250 words. So if I wanted to know how many words I could read in 8 minutes, I'm putting 8 in for x and I'm multiplying 8 times 250. So first substitute in W of x equals 250x. You substitute 8 in. W of 8 is equal to 250 times 8. Simplify that down. W of 8 equals 2,000. If you're wanting to find the range of a function, they say the domain of g of x equals 4x minus 12 is 1, 3, 5, and 7. So those are my x values. And if I'm wanting to find the range, I'm just finding the y values. So remember that the domain is the x values and the range is the y values. So I have myself a function table right here, and I can substitute those values in. So if I put 1 in there, which is our first part of the domain, I put that in there. 4 times 1 minus 12 is negative 8. Then I'm going to put 3 in there. You can see that's the second part of my domain. So 4 times 3 is 12. 12 minus 0. I'm sorry, I was thinking ahead. 12 minus 12 is 0. And if I put 5 in there, 4 times 5 is 20 minus 12. That would give us 8. And with 7, put 7 in there and I get 16. So the range is negative 8, 0, 8, 16. So basically for all of these x values, these are the y values that match up with them. Negative 8 goes with 1, 0 is the y value for 3, and so forth.